In this episode, and probably the 3 following episodes of Finno-Ugric Machining, we are going to install a PID controller for my mini kiln. I purchased a mini kiln from eBay, and that is very practical unit. It's so small, it's exactly what I need. I don't need a big furnace. I just need something that I can heat up my pieces of metal into desired temperature, and then whatever heat treating to do with those. That temperature should be controlled, and PID is exactly what is needed for that. Let's go on with that one. Well, I started this adventure by taking this unused kiln apart. This kiln has never been used, yet it was built over 60 years ago. Back then, the insulating materials like aerogel and ceramic fibers were available only on books from Arthur C. Clarke. Instead of aerogel or ceramic fibers, this unit was insulated by vermiculite and asbestos. Vermiculite is messy, and the insulating properties are not that good. Asbestos can be hazardous if the asbestos fibers get airborne. It is a very good idea to squirt water on asbestos before handling to keep its fibers within. I will replace the vermiculite and asbestos with a ceramic fiber blanket, which has superior insulating properties and is not as hazardous as asbestos. Ceramic fiber blanket is available on most auction sites. The heating elements of this kiln are embedded inside 5 tiles, each tile delivering about 300 watts of heating power. This construction protects the heating resistors from mechanical and chemical damage. However, this also means that the tiles will become equally hot on both sides, so the insulation must be really good to prevent the kiln from doubling as a hot plate. The PID controller needs a measure of the temperature from inside of the kiln. The measuring element in this case is a thermocouple, which is a very stiff stick with ceramic insulators. The installation guide states that 2/3 of the length of this stick should be placed inside the kiln. The same guide states that the thermocouple could be bent as needed. Well, it is so stiff that it will break the ceramic insulators when bent. Instead of trying to route the thermocouple past the tiles, I figured out it would be easier to just stick the thermocouple right through the back wall. Consequently, this means that a hole needs to be drilled on the back tile and also on the back of the metal cover. So, let's make a hole on the tile first. Well, here I am making a hole through the back tile. There is a rubber mat under the tile to make the tile steady under the drill. I sharpened the masonry drill bit the best I could in my CBN wheel. I am using very gentle pressure and slow drilling speed to keep the tile in one piece. If I would just go on drilling from this side and let the drill go through, it would most probably chip the other side of the tile quite badly. To avoid the chipping, I will drill a counter hole from the other side of the tile. Since the holes meet somewhere in the middle of the tile, chipping is less probable. The insulation ceramics in the thermocouple are not round. They have an oval shape and therefore the hole needs to be adjusted accordingly. I use an old and dull file to shape the hole. Okay. There you are. The hole for thermocouple through the back tile is ready. Next, let's put the kiln core back together. The whole core is constructed on top of this steel plate. It is held together by the geometry of the pieces and a soft iron wire. Kinks must be made on the iron wire to give it some flexibility to prevent it from cracking the ceramic parts. I actually ended up redoing this with 4 iron wires instead of 3. Now let's make a hole at the backside of the steel cover. Here I'm trying to figure out the place for the hole. Now I'm drilling a pilot hole with a 3mm drill. A step drill is used to make the hole bigger. The step drill has a tendency to wander to some random direction. In this case it wandered about 3mm off the place. So let's correct the place of this hole with a trustworthy tool. This sheet metal punch can be used to punch holes to thin material. It does not wander, and the resulting hole is perfectly round and has negligible or no burr. Now I am happy with the holes. In the next episode of Finnugric Machining, it will be the pedestal for this kiln. Till then, see you!